Welcome back. Let's proceed to the same section of chapter 7, angles of elevation and depression. We did angles of elevation in the previous video, so this video will focus on angle of depression. And hopefully by the end of this video, you will be able to solve some simple trigo problems using angle of depression. Now let's recall, what is angle of depression? Is it formed when you look up or when you look down? Okay, it's formed when you are looking down. So this hero is looking down at a helpless foot. So since he's looking down with an angle of depression. Now how do you draw angle of depression? First, you draw a horizontal line, and then you draw the line of sight. And where do you draw the angle then? You draw it here. Now what did you learn in the previous lesson? Try to do a bit of recall. You learn to apply angle of elevation in to solve some simple trigo problems, like for example trying to find the height of a building, trying to find the angle of elevation, or to find the distance between two objects which are looking up at another object. Okay, but in all of this application, what is the common factor here? The common idea, we always use the angle of elevation and create something. What is it? Right angle triangle. And what did we apply on the right angle triangle? Tuakaso. And that is what you learned in the previous lesson. With an angle of elevation, form your right angle triangle, apply Tuakaso. Now these same ideas will be used for angle of depression. Let's proceed with this example. Now read the question carefully. Pause the video. Okay, you are given a building and you are the black circle on the ground, and you are you are given the angle of depression, which is 60 degrees. Now be careful here. Who is looking at who? Okay, try to remember, how do we identify who is looking and who is being looked at? Okay, the angle of depression of something, that something is the object being looked at. Angle of depression from something, that something is the object which is looking. So in this case, the top of the building is looking down at the ball. So you draw the horizontal line where? At the top of the building, since we always draw horizontal line at the object which is looking. So draw it. After that, you draw the line of sight from the top of the building to you. Sorry, this is a ball, not you. Okay, so you draw the line of sight from the top of the building to the ball. Now everyone, where is the angle of depression? It is right there, 60 degrees. Okay, in the previous lesson we did a lot of angle of elevation, so please don't be confused. Today in this video we are doing angle of depression. Now what did we do after we draw the angle of elevation? We construct a right angle triangle. Now we just drew the angle of depression. Can we construct a right angle triangle using the angle of depression? Can you see a right angle triangle? Okay, if you can see, there are actually two right angle triangle. Okay, let me focus on one at a time. So the first right angle triangle can be formed from here. Okay. Now, since we are interested in finding the height of the building, let's label it capital H. Okay. So after you form the right angle triangle, what do you use? Tuakaso. Okay. And tuakaso is what? Sine, cosine, tangent. And what do we always attach to sine, cosine, tangent? An angle. Look at the right angle triangle. What is the given angle? Besides the 90 degrees, is the 60 degrees. Okay. Now, look at the 60 degrees in the right angle triangle and identify which sides are the opposite, adjacent, and hypotenuse. Okay, you will realize that we will use the H, which is the opposite, and the 50, which is the adjacent. And opposite and adjacent is tua, tangent. And inside the tangent, we put in our angle 60 degrees. So tangent is opposite over adjacent, which is H over 50. And how do you solve it? It's very straightforward. Okay, just put tangent 60 over 1, cross multiply so that you don't deal with any more fractions, and press your calculator. If your answer is not exact, how do you round it off? You round off to 3 sig fig. Okay, take a moment to understand this. I hope you know why we use tangent, because H is opposite to 60 degrees and 50 meters is adjacent to 60 degrees. Opposite and adjacent is tangent. Now recall earlier I said that we could see two right angle triangles here. One is as shown here. The other right angle triangle is where do you think it is? It's here. Okay. And H will be the height of the building. Now, there is something wrong with this right angle triangle. What is it? Okay, we have the H, we have the 50 meters, but we are missing an angle. In the triangle that we used earlier, we had an angle besides the 90 degrees. But in this new right angle triangle, we don't have an angle besides the 90 degrees. Actually, look at the horizontal line at the top there, and look at the ground. Is the ground also horizontal? Yes. So you actually have two horizontal lines. And when you have two horizontal lines, these lines are in fact parallel. And what can you recall about angles in parallel lines? There are three of them: alternate angle, interior angle, corresponding angle. In this case, I can use alternate angle. Okay, alternate angle is like something, it's like what people say, from the Z. What I mean is, this is also 60 degrees. Okay, this red angle is 60 simply because it is an alternate angle. Okay, I can do this simply because the horizontal line and the ground are parallel to each other. If you are confused about alternate angles, please ask your friends or pause this video and do a little bit of research. Okay, now our right angle triangle has an angle 60 degrees. So we can now use tuakaso. And we still use tangent 60 degrees because H is opposite to 60 degrees, 50 is adjacent to 60 degrees. So opposite and adjacent, we use TOA, tangent. Okay, the steps here are the same as what we did just now, and the answer is also the same. So what did we apply here? We use the angle of depression to construct a right angle triangle, and then we use Toa Kaso. But then angle of depression here is special because I can actually construct two right angle triangles using property of parallel lines. Okay, now notice the following. Here, the 60 degrees is the angle of depression of the ball from the top of the building. Over here, this is 60 degrees and this is the angle of elevation of the top of the building from the ball, and both are exactly the same. Now take a moment to understand this. Angle of elevation of the top of the building from the ball is exactly the same as angle of depression of the ball from the top of the building. So what did you learn from example 1? We apply what we learned in the previous video. We draw the angle of depression, we construct a right angle triangle, and when we construct the right angle triangle, we found out that we can actually draw two right angle triangle. Which one is better? That is up to you. This triangle is obvious, but this triangle is not so. But if you decide to use this triangle, take note, this is also 60 degrees. Okay, by using property of parallel lines, which is called alternate angles. And then from the example, we arrive at one important fact. Angle of depression of point A from point B is the same as angle of elevation of point B from point A. Now this is an important fact. If you still cannot see this, pause the video, okay, rewind a bit and discuss with your friend. Okay, let's try on the following example. There's a bird flying above a tree, and right now at this moment the bird is 5 meters away from the tree. The question gives you the angle of depression of the top of the tree from the bird, okay, of the top of the tree and the bottom of the tree from the bird. So how do we begin? We need to draw the angles of depression. Once again, what are the things that you need to do before you draw? First thing, you need to identify which is which. So the top of the tree and the base of the tree, they are both objects being looked at. The bird is the object which is looking. So at the bird, you draw a horizontal line. Since there are two objects being looked at, you need to draw two right angle triangles. So first, let's draw the line of sight. This is the 30 degrees, and the other line of sight, this is 40 degrees. Now, can you see two right angle triangles formed here? Okay, and we are interested in finding the height of the tree. So this is a diagram, and try to recall what we did in the previous video. We break up this triangle into two smaller right angle triangles. So observe carefully. This can be split into the big right angle triangle and the smaller right angle triangle. Okay, now why did we split them into two right angle triangles? So that we can use tuakaso on each of them. So how do we find H from here? H is simply this blue line minus this purple line. Now pause this video to study carefully. Okay, to find the length of the blue line and to find the length of the purple line, you have to use tuakaso. You should get the following. If you do not know how they are arrived at, please pause this video and discuss with your friends. Press this in your calculator and you should get an answer. If the answer is not exact, always round off to 3 sig fig. Okay, a final thought before I end this video. Now, this section is section 7.1, which focused on angles of elevation and depression. How do you picture them? Angle of elevation is when you look up. Angle of depression is when you look down. So if just looking up, looking down. Then how about looking left or looking right? What are they called? For example here, the car is on the left of the person. If looking up, angle of elevation, looking down, angle of depression, what is looking left and right called? Okay, this is actually called bearing. And we will deal with bearings in the next lesson.